First of all, we take the 32 bits, which we could write in hexadecimal as 8 zeros up to 8 Fs, and break it out into 4 pieces. So I've got the same digits, just with some space between them. Normally, instead of writing hex digits this way, though, we convert each of those 4 hex digits to decimal and put a dot in between them. So this is dotted decimal form. The dot here is obviously not a decimal point, but it is separating decimal numbers. So we have 0, 0, 0, 0 to 255, 255, 255, 255. The extra structure comes in because numbers to the left point packets towards a more general direction, and numbers to the right here point packets to more specific directions within that general direction. That is, hosts that are physically close to each other, in the sense that packets need to be sent that direction, are going to have similar IP addresses. That doesn't mean that two similar IP addresses are necessarily next to each other. They could be very far apart. But if they are similar, they're more likely to be close together than not. For example, there are various machines in my office: thistle.cs.utah.edu, shanghai.cs.utah.edu, Rains. All of these have numbers that start 155, 98, 69, or 68. 68 is still close to 69. Some department servers, like Thebes and Memphis, have 155, 98 numbers, but they have 65, which is a bit further away, and not coincidentally, they're not sitting in my office. www.utah.edu is a server that's sitting on a campus, and it has a 155.98 number, but not something in the 60s, it's a 186 number. Finally, www.cs.utah.edu currently is hosted by WordPress, so it's not on campus at all, and it doesn't have a 155 number. It starts 141. So you can see again that the address is kind of most specific on the right and least specific on the left. It turns out that every 155.98 dot something address is going to be on campus at the University of Utah. We don't usually write it this way, though, with X's. We usually write 155.98.0.0/16. This is called an IP prefix. It looks like an address, but ending in some zeros with a slash and a number here between 1 and 32. That number is how many of the bits you should pay attention to. So 16 here means we pay attention to the first 2 bytes, and not the last 2 bytes, which are written as 0. 98 is an even number, so its low bit is also 0, but it's an important 0, because we need to look at all first 16 of the 32 bits, including that ending 0. Whereas these zeros really are just zeros. So if something's not in the prefix, it'll be 0. If something is in the prefix, it'll be 1 or 0. Numbers 155, 98, 68, and 69 are both in the School of Computing's untrusted network, machines that are managed by individuals like me. We could write down this address, where this last number has 2 possibilities, but they both differ in their low bit, an even number versus odd number, like this: 155.98.168.0/23. /23 means that these first 23 bits, 155, 98, 68, have to be those bits, but the bottom 9 can be anything and still refer to this part of the network. That means that this last 0 can be anything, 0 to 255, but it also means we can turn this even number to an odd number because we have 1 more bit, and that's how we get to 69. So again, this IP prefix here, /23, is referring to the same thing as writing it this way with X's. This organization, putting machines that have these high bits similar in a similar routing direction, this is called classless interdomain routing, or CIDR. It's classless as opposed to the original scheme. Just the first number represented a particular class, and packets would go in that direction. But CIDR generalizes that to have any number of bits as a prefix, and organizing routing around those kinds of prefixes.